Good morning. Today we're going to start looking at multiplying and dividing exponential expressions with coefficients. Of course, multiplying and dividing is referring to the product and quotient rules. Coefficients are numbers in front. To do this, let's take a look at a couple of breakdowns. You should already be able to apply the quotient rule, so why don't you go ahead and take a look at these first five. Pause the video if you'd like to, and then I'll go through them. So x to the third times x to the seventh, we keep the base and we add the exponents. Here I see x to the third times x to the seventh, so we're really looking at 2 times x to the 10th, which is just 2x to the 10th. Well, if I take a look at this one again, I see I see x to the third times x to the 7th, but now I see a 9 in the front, so that would be 9x to the 10th. Step 4, I see 2 right next to the 9. So I'm just going to do 2 times 9, which of course is 18x to the 10th. So how does that apply to number 5? Well, here's the 2 and here's the 9. Here's the x to the third, here's the x to the 7th. The only thing I see going on here is multiplication. So what this really is 2 times x to the third times 9 times x to the 7th. But the commutative property lets me move things around, so this is really the same as 2 times 9 times x to the third times x to the 7th, which looks a lot like step 4, so I think this is just going to be 18x to the 10th power. So I want to use that same strategy. Based on the previous exercise, evaluate 3x to the 6th times 10x to the 5th. So what this really is 3 times x to the 6th times 10 times x to the 5th. I can rewrite that using the commutative property and put the 10 out front. So I really have 10 times 3 times x to the 6th times x to the 5th. I know 10 times 3 is 30. I apply the product rule right here, so x to the 6th times x to the 5th is x to the 11th, since I keep the base and add the exponents. Okie dokie. The same thing works with division. So if I look at the second column, x to the 9th divided by x to the 7th, apply the quotient rule, keep the base, subtract the exponents. Now what I have is 12x to the 9th divided by x to the 7th. Okay, so what this really is, that says 12 times x to the 9th. So I'm going to break this apart. It's really 12 times x to the 9th over x to the 7th. And the 12 is actually 12 over 1. So what this gives me, we already know that x to the 9th divided by x to the 7th is x squared. There's just a 12 in front of it. So this is equal to 12x squared. Step 3 is a little bit more complicated, but notice that we still see the x to the 9th divided by x to the 7th. The only difference is there's a 4 on the bottom. So what's the number on the top? The coefficient has a number 1. So this is really 1/4 times x to the 9th over x to the 7th. Well, I already know that x to the 9th over x to the 7th is x squared. So I just keep the 1/4 in front of it. Okay, and technically speaking, this x squared can go back on the top of the fraction. So it would be x squared over 4, or 1x squared over 4 if you want. Okay, the next part, well, notice that these are two separate fractions. It started separated the way that I had already done these ones. So I just look at what I have. 12 divided by 4 is 3. X to the 9th over x to the 7th is x squared. No big deal. Well, now look, that step 5 is all of this just put together. 12x to the 9th over 4x to the 7th. Basically, it's just a put together version of this. So I'm going to separate it back out as 12 over 4 times x to the 9th over x to the 7th, which is equal to 3x squared. Okay? See if you can do this on this example. Pause it if you have to, but I'll do it now. I look at this being 27 divided by 9 times x to the 5th over x to the 9th. I know that 27 divided by 9 is 3. I can apply the quotient rule to keep the base and subtract the exponents. Well, 5 minus 9 is actually negative 4. So my answer is 3x to the negative 4th. Okay? We will actually keep the bottom part as our summary in class tomorrow. So you can flip the page. We're going to look at a couple of these. If you feel like you can do it without me, pause the video and try your questions. But I'm going to go through the answers right now. So this is really 8 times p to the 4th times 3 times p squared. So if I rearrange things, I really have 3 times 8 times p to the 4th times p to the 2nd. 3 times 8 is 24. P to the 4th times p to the 2nd. Keep the base, add the exponents. My final answer is 24p to the 6th. Okay? Please skip down to number 12. In number 12, I have 3a cubed b to the 5th c to the 7th times negative 5a squared b to the 4th c to the 6th. There's a lot of variables here, a lot of different things that look like it's going on, but it's really not that bad. I can do the same thing that I did before, just recognize that I have 3 different bases. So the first thing I'm going to do is get rid of those parentheses, since all they mean is multiply. So this says 3 times a to the 3rd times b to the 5th times c to the 7th times negative 5 times a to the 2nd times b to the 4th times c to the 6th. Notice that the only operation we see is multiplication. Order doesn't matter when we multiply, so I'm going to switch things around so that the common things are next to each other. So I'm going to do negative 5 times 3, since those are the coefficients, times a to the 3rd, and I'm going to move this a next to it so it's times a to the 2nd, times b to the 5th, I'm going to move the b to the 4th, times c to the 7th, times c to the 6th. Now I'm just going to apply my rules. Negative 5 times 3 is negative 15. A to the 3rd times a to the 2nd is a to the 5th. B to the 5th times b to the 4th is b to the 9th. C to the 7th times c to the 6th is c to the 13th. Okay, so my final answer here is negative 15, a to the 5th, b to the 9th, c to the 13th. Okay, the next one should actually be a little bit easier. Number 3, I have negative 10 r to the 3rd times 2 r to the 7th. I will apply the same strategy. Negative 10 times r cubed times 2 times r to the 7th. Rearrange things so that it really says negative 10 times 2 times r to the 3rd times r to the 7th. Apply our integer rules. Negative 10 times 2 is negative 20. Apply our product rule. R to the 3rd times r to the 7th is r to the 10th. Okay. Next, let's go down to number 7. Number 7 is really the same idea as number 12, just has 3 terms instead of 2, but it doesn't change the way we think about it. This is 9 times a to the 4th times b to the 6th times 3 times a squared times b to the 8th times 2 times a to the 5th times b to the 3rd. By the way, hopefully eventually it won't be necessary to do all this. We can figure out a quicker way to do this. But right now I'm going to rearrange. I'm going to put all the coefficients out front. So I'm going to move the 2. I'm going to move the 3. And then I have the 9. And then I have a to the 4th. I'm going to move the other ones and have times a squared times a to the 5th. And then I have b to the 6th times b to the 8th times b to the 3rd. And now I apply my rules. 2 times 3 is 6. 6 times 9 is 54. So I have a coefficient of 54. Product rule for the a's, keep the base, add the exponents. product rule for, oh, I'm sorry, I forgot one. So that should be 4, 6, 11. So a to the 11th power. But then I have the b's. 6 plus 8 is 14, plus 3 is 17. So I have b to the 17th. Final answer, 54, a to the 11th, b to the 17th. Okay. Now a couple of division problems. Move up to number 2. This says negative 40y to the 12th divided by 5y to the 4th. Split things up and get negative 40 divided by 5 times y to the 12th divided by y to the 4th. Well, negative 40 divided by 5, remembering our integer rules, is negative 8. Y to the 12th divided by y to the 4th, use the quotient rule, and get y to the 8th power. Final answer of negative 8, y to the 8th power. Okay, skip down to number 4. It's the same thing. This is going to be 30 divided by 2 times x to the 9th divided by x to the 6th. 30 divided by 2 is 15. X to the 9th divided by x to the 6th is x cubed. Don't really need that multiplication sign, so my answer is 15x to the 3rd power. Alright, skip up to number 8. The reason I want to look at this one is notice that the coefficient on the numerator is smaller than the coefficient on the denominator. But it doesn't change the way I do things. This will be 2 over 8 times m to the 15th over m to the 13th. Okay? Just be careful, 2 divided by 8. Many students think it's 4, but it's really not. It's really 1/4. And then I have my quotient rule, so I get m to the 2nd power. That really is an accurate answer. It might be a little bit better just to put the m to the 2nd on the top of the fraction, so it's m to the 2nd over 4 as our final answer. The very last one to look at will be number 11. Ooh, decimals. But it doesn't change the way we think about it. So it's 0.5 over 0.25 times h to the 5th over h to the 4th. This is a little bit challenging. If you have to, get a calculator. 0.5 divided by 0.25 is just 2. So this would give us 2. H to the 5th divided by h to the 4th is h to the 1st. I don't need the 1, but I can definitely put it there. We will finish up the rest of the examples in class tomorrow, but this is just applying the product and quotient rules with coefficients. See you tomorrow.